Let's talk about invariant. In other words, things that are not going to change regardless of the reference frame. And so there's actually two invariants when we start talking about in relativistic terms. One is the speed of light. That speed of light is constant. This is speed of light. But another one actually comes out of the original thought experiment that we talked about a couple of videos back. If we have something moving at some speed v, and this is some distance h here, and it shoots light up and the light comes back down. So if we break that triangle down, so if we look at that triangle right there, this distance here is h, this distance here is 1/2 of vt, because when the light comes back down to here, the distance it travels, I guess center to center distance, is delta x, and that's equal to the speed times time. And therefore, half the distance would be 1/2 vt. So the hypotenuse here, since this is a right triangle, there's symmetry going on here, and is that this is the square root of h squared plus 1/2 vt squared. Well, recognize that the total distance traveled here is, well, sorry, let's do it. Distance equals, speed is distance over time. We're saying the speed of light is constant, and the distance traveled would be 2 times the square root of h squared plus 1/2 vt squared over the amount of time it took. So that is time in that particular reference frame. That's the speed in that particular reference frame. So therefore, we have ct is equal to 2 square root of h squared plus 1/2 vt squared, which is c squared t squared is equal to 4 times h squared plus 1/4 v squared t squared. Distribute the 4, we have c squared t squared is equal to 4h squared plus v squared t squared. Recognize that v times t here is just the distance traveled. I guess we sort of went in a circle there, but we have c squared t squared is equal to 4h squared plus the distance traveled squared. And so we have 4h squared is equal to, bringing that over, we have c squared t squared minus delta x squared. So if we were in a different reference frame, in other words, this object's traveling at a different speed based upon a different observer, well, all the math stays the same. The only difference is that time and distance are not the same. So in a different reference frame, we would have 4h squared is equal to c squared t prime squared minus delta x prime squared, where prime is just a different frame. In essence, this relationship here is equal to 4h squared, equal to 4h squared. We have a second invariant here, that c squared t whatever reference frame squared minus delta x in that same reference frame squared is equal to a constant. So we have that invariant as well.